and turn on live captions. We already talked about most of this. Let me see if we got all the way through. I don't think we got through. We talked about symmetry. I know we talked about symmetry. Let me just start from symmetry and go there. Okay, if something is symmetrical, and we talked a little bit about this, if you have f of x is equal to x to the second, x to the fourth, x to the sixth, x to the even power, it's what we call an even function. An even function is symmetrical about the y-axis because you have a parabola. It is symmetrical around the y-axis. So that means that this side looks like this side and this side looks like this side. So if you have a even function by itself, we know it is symmetrical around the y-axis. If we have an even function, x cubed, or odd function, x to the fifth, x to the seventh, x to the odd, then we have what we call a swerve. And it is symmetrical around the origin. Okay. Now, if you have a function that is symmetrical around the x-axis, it is usually not a function. It is usually like a hyperbola or a circle. I'm just going to use a hyperbola. And for every x, let's say this is x is equal to 2. You have a y that's maybe 4 and a negative 4. You have 2 y points. So for every 1x, you have 2 y's. Well, 1, that's not a function. And 2, it is called a hyperbola or a circle. Circle, ellipse, and they are symmetrical around the x-axis. Okay, so there's your 3 possibilities: the x-axis, the y-axis, and the origin. Now these are the 2 right here that we're going to be talking about as far as plugging and chugging to see if it's an odd or an even. And I'll show you that in just a second. This we really don't have to worry about because 1, it's not a function, and 2, that's another section entirely. So I don't know, somebody look in your notes. Did we cover that? Yes or no?
No, we did not.
Okay. Did anybody look and see what the last thing we did cover? Okay, that's all right. I'll take what I can get.
The last problem I had was f of x at 55 and 4,000. So it was like a problem one.
Okay, hold on. I remember that now. Right there. There it is. Is that the one we went over?
Yes.
Thank you. That's what I was asking. So thank you. It only took me, what, 10, 15 minutes in the class to get it, but I got it. Thank you. Love the communication. Love y'all's communication skills. Thank you very much. All right. So Yeah, pretty much. Stretching, compressing, we talked about that, so I ain't got to worry about that. And this is in your parent graphs. That is a 1 over x. Okay, so we're okay. Go ahead and write down the following. And this is red, so you might want to, if f of negative x, if you plug in a negative x and you get f of x, then that is called an even function. If you plug in negative x and you get negative f of x, then that is an odd function. That's where you plugging and chugging. And we're probably going to do an example here in just a second. If it's an even function, then it is symmetrical around the y-axis. If it is an odd function, it is symmetrical around the origin. Now, when do you use this? Well, when you have more than just x squared or x to the third. You may have a function like x to the third plus 1 over x squared. Well, see, you don't know whether it's an odd or an even function because you got an x cubed and x squared. So you're not going to be able to tell if it's odd or even. Okay? So let's see if they give us an example. Yep, there's an example right there. So this is a test question. It says y is equal, or f of x is equal to 2x squared over x squared plus 1. Now, the test at the top says I've got to plug in negative x squared and see what I get. So I'm going to do this one right now. And this is f of x. So I'm going to rewrite it, 2 parentheses squared over parentheses squared plus 1. And make sure that's not a cube. It's not. Okay. I'll make sure I wrote down the problem right. And I'm going to plug in a negative x here and a negative x there. Well, that's going to give me 2x squared over x squared plus 1. Well, heck, that's what I started with. So this is an even function and is symmetrical around the y-axis. Let's take a look. Handy dandy calculator. Clear. Clear. And y is equal to 2x squared, parentheses, 2x squared, close parentheses, divided by, parentheses, x squared plus 1. And let's see if it's symmetrical around the, hold on, let me turn off my stat plot. Turn off, now hit graph. And zoom 0. Zoom 6. There you go. And you see it's symmetrical around the y-axis. Okay, so that's the test question. Now let's do another one. Let's do one that, and there you see it is symmetrical around the y-axis. Here's one. X cubed minus 3x. F of x is equal to x cubed minus 3x. And we're going to plug in negative x, because first we got to see if f of negative x is equal to f of x. Then we need to see if f of negative x is equal to negative f of x. So there's our two tests. So I'm going to plug in parentheses cubed minus 3 times parentheses, and I'm going to plug in negative x. Well, negative x cubed is equal to negative x cubed. And negative times negative, that'd be a positive 3x. Well, that's not equal to this, so you can forget about that one. And we know that this is f of negative x, so negative x cubed plus 3 is equal to negative parentheses x cubed minus 3x. So distribute that negative, and we get negative x cubed plus 3 is equal to negative x cubed plus 3. So that does check. So we know we have an odd function, and it is symmetrical around the origin. So let's check it out on the calculator. So y is equal to, clear, x cubed minus 3x. X cubed minus 3x. And you can see it is symmetrical around the origin. Now, those are two good test questions that I would give you on whether something is odd or even. Anybody got a question? I don't know why I'm asking you. If you have a question, I'm not going to ask it. You'll just, be silent in ignorance. You won't ask a question, so I'll just keep on going.
You have a work email.
And of course, they're giving you a circle here because the circle is symmetrical around the y and the x-axis. I'm not going to ask you that on a test, but it is symmetrical around the x-axis and the y-axis. But the reason I don't include the circle or the hyperbola or the ellipse is because they're not a function, and right now that's all we're studying is functions. So that's why I'm kind of not including it on the test. All right, that's 4.1. Now let's go to 4.2. Let's see what this is. Okay, I know what to do. All right, so and you may have heard me say this before, in pre-algebra and algebra 1 and algebra 2, pre-algebra 1, algebra 2, somewhere in there, they told you to add two functions. And you put a 1 here, and you put a 1 here, you distributed that 1, and you distributed that 1, and that would be x plus 2 plus x minus 3, and then you took that x and that x, And that'd be 2x because you got a 1 right there, 1 right there, and then 2 minus 3 is -1. And you were taught to subtract. X plus 2, subtract x minus 3. Well, there's a -1 there and a +1 there. You were told to distribute to get rid of the, and that left you with x plus 2 minus x plus 3. And that's x minus x. Well, they cancel. And +2 plus 3 is 6. And you were taught to multiply.
5.
I'm sorry. Thank you. I suck. But I appreciate you communicating with me. Thank you. All right. So x plus 2 minus x minus 3. So let's go with x plus 2 times x minus 3. And you use your FOIL method. I do not pronounce FOIL, just like I don't pronounce DOG, because there's always somebody in the group that's going to say something about the way I say FOIL or the way I say DOG. So I don't say them, except when I'm talking about Georgia Bulldogs and their dogs, and they're it. All right, x times x is x squared, -3x, +2x, and -6. And that's going to give me x squared plus -x minus 6. So everybody should look at these three and go, oh yeah, I remember how to do that. Well, what about division? Well, you really can't divide these two because all you're going to get is x plus 2 divided by x minus 3. That's all you're going to get because there's not really anything you can do. So that's division. So you go up a couple of years and now you're in a college algebra class. You got to hold up your pinky when you say certain things. So now we're going to say f of x is equal to x plus 2 and g of x is equal to x minus 3. And I would like for each of you to give me f plus g of x, f minus g of x, f times g of x, and f divided by g of x. And what are all those? Same damn thing you did back in pre-algebra. You would be surprised on how many students are lobotomized over this. And they've been doing it for years. There's no difference. You hold your pinky up and you talk funny. That's basically the difference. F plus g of x, you take this one, you add it to that one, and you get 2x minus 1. You take x plus 2, you subtract x minus 3, and you get 5. You multiply them, and you get x squared minus x minus 6. And you divide them, you get x plus 2 over x minus 3. So I'm not going to spend a lot of time on the 4 operations because you've been doing these 4 operations for 2 or 3 years before you got here. Now, some of y'all may not have taken Algebra 2 and Algebra 1 since the, Reconstruction after the Civil War. I don't know. But you have done this before. I want to make sure you understand that because I don't want you to go into these these functions and compositions like you don't know what you're doing. You do know what you're doing. Capiche? All right. So let's move to what you suck at. Y'all remember doing something like this in Algebra 1 and Algebra 2? Algebra 1/2, I don't know. I don't think it would be in pre-algebra. 2x plus 3y is equal to 6, and y is equal to x plus 4. Does anybody remember what we did here when you had something like this? Anybody want to take a guess?
You'd plug in.
Plug in x plus 4 into what? Y. Does anybody know what that's called? Starts with an S.
Substitution.
Okay, so don't give me some head nods or some thumbs up if you remember doing something like this. Okay, I got a bunch of head nods and a bunch of, okay, so what is this? I hope I spelled it right. I always want to spell composition with compost. So if I didn't spell it right, just go jump in a lake. All right. Composition is nothing but what? Substitution. Everybody with me?
Work email.
Okay, because this is where a lot of people get, confused. So I'm going to show you how to do composition. F of x is equal to x plus 4, and g of x is equal to x minus 3. I would like for you to give me f composed of g, g composed of f, f composed of f, and g composed of g. So, what I tell students, take your handy dandy highlighters, and I'm talking to people that suck at this. You take a highlighter, green highlighter, and you highlight these first letters. And that means that you're going to rewrite those green ones with a big set of parentheses. So I'm going to take my handy dandy. So I'm going to rewrite F with a big set of parentheses. So big set of parentheses plus 4. G, big set of parentheses minus 3. F, big set of parentheses plus 4. And G, big set of parentheses minus 3. Now I want you to take an orange highlighter or another color highlighter. I want you to highlight the second letter. And that means you're going to take whatever that is, you're going to substitute it into your equation. So G is x minus 3. F is x plus 4. F is x plus 4. And G is x minus 3. And now you just do your algebra. So this is going to be x minus 3 plus 4, x plus 1. X plus 4 minus 3 is x plus 1. Now, I couldn't have done that in a million years, playing that. X plus 4 is equal to x plus 8. And x minus 3 is x minus 6. And that's how you do composition. All right, so let's do a nerding, because y'all know how to do this. This is what y'all suck at. I mean, 110 students and 109 students. So let's do another one. F of x is equal to, oops, no, I don't want to do that. F of x is equal to x squared minus 2, and g of x is equal to the square root of x minus 1. Now I want you to do f composed of g, g composed of f, f composed of f, and g composed of g. I sound like Katharine Hepburn. And oh, forget it. Y'all don't even know who that is. So uh-oh, Miss Ray, what happened to you? Miss Ray left us. Where'd she go? Maybe she'll come back in. All right, can you work on that? Okay, so I'm going to rewrite all of these with a big set of parentheses. So that means F, I'm going to rewrite with a big set of parentheses. And I'm going to color them green. I'm going to rewrite square root of blank minus 1 equals parentheses minus 2 and equals square root parentheses minus 1. So take my orange highlighter and I'm going to plug in this guy. So take my orange marker and square root of x minus 1. F is x squared minus 2. And F is x squared minus 2. And G is square root of x minus 1. All right, now all you got to do is just do what you need to. What happens to the square in that square root? Somebody tell me. Cancels, Hubert. Yeah, that's right, class. You suck. And you get x minus 1 minus 2, which is x minus 3. This one you can't do that because there's too much going on down here. But you can do x squared minus 2 minus 1, which is the square root of x squared minus 3. And this is shortcut number 2. So that's going to be x to the 4th minus 4x squared plus 4 minus 2, which is x to the 4th minus 4x squared plus 2. Check my algebra. I think that's right. And then this one, I'm going to take the square root of the square root. There's not really much you can do here, except you can't take that because that radical's there. You really can't do nothing with this, so I'm just going to rewrite it as x minus 1 to the 1/2 minus 1 all to the 1/2 power, or you can just leave it like this. There's nothing really you can do here. And I guarantee you there's somebody in this room that when you had compositions, you didn't know what the hell to do. That's how you do it. Anybody ever been confused by compositions? Anybody? Just give me a nod or a no. Okay, so everybody knows what they're doing on that. Okay. All right. Okay, so the next thing, and that's what we're going over right here, quotient. I just covered all this, and composition is down here somewhere. Let's find the composition. There it is. There's one right there. Here we go. Let's do this one for an added question. All right, this one says f of x. Wait a minute. Why do they got to do something? Why do they got to twist things around? Okay, we're not doing that one. We're going to do f of x is equal to 2x minus 5, and g of x is equal to 6 minus x squared. All right, I want you to do f composed of g, g composed of f composed of f, and g composed of g. Give you about 3 minutes. It's 10:25. We'll do it at 1028. Go ahead. Work it. Okay, it's 1028. So I'm going to plug in G. I'm going to plug in F. I'm going to plug in F. And I'm going to plug in G. (12) minus 2x squared minus 5. And 12 minus 5 is what? 7. Y'all check my math, please. This is a -1, but you've got shortcut number 2 right here. So I can't do that -1 until I do the shortcut. So 6 minus 1 times 4x squared plus 20x plus 25. And now I can distribute 6 minus 4x squared minus 20x minus 25. And that's going to be -4x squared minus 20x. -25 plus 6 is -19. And that should be your answer for that. Distribute here. That's going to give you 4x minus 10 minus 5. And that's going to give you 4x minus 15. And then a -1 here, but I can't distribute that -1 until I do shortcut number 2, just like up here. So that's going to give me 6 minus 1 times 36 minus 12x squared plus x to the 4th. 6 minus 36 plus 12x squared plus x to the fourth. And the final answer is x to the fourth plus 12x squared. Negative 36 plus 6 is negative 30. And those are two examples of composition of functions that you should be able to do. Okay? Right, complaint. Let's see what else is in 4.2. That's it. And let's look at 4.3. Okay. What is a one-to-one function? And what is an inverse function? How's the best way to put this? Let's go with graphic calculator. And let's graph x squared, x quantity squared, hold on, x squared, and the square root of x, or x, excuse me, to the net 0.5 power. I don't know why I start yawning in this class and the next class. So you got x squared and the square root of x. I want everybody to focus on this right-hand side. And I'm going to do zoom. And I'm going to do first quadrant. And then I'm going to graph y is equal to x. And I'm going to do that
message coming in on secured channel.
in a black dash line. I don't know why I keep yawning. And I'm going to make that a dash line. Where's the dash line? Oh, I've drawn a dash line on here before. Why can't I draw it now? Well, I guess I can't draw a dash line anymore. And I'm going to make it X. Somebody tell me what they see here. And in fact, I'm going to blow it up even more. Blow it up down here in a quarter. I have not yawned all morning until I get to this class. All right, zoom. Pretty bad when your teacher bores himself. All right, zoom in. And I'm going to go down here. Okay, somebody tell me what they see with the magenta line and the blue line. What do you see? That means I want somebody to say something. You know, communicate.
They intersect.
They're what?
They intersect.
They intersect, yeah. But what do you see about them, the two functions around the black line? What are they of each other? What are they?
Are they inverse?
They're inverses, but what also are they? What do they look like? I'm trying to get y'all to say a word, but I don't think it's going to happen. One, only 2 or 3 of y'all are going to talk to me, and the other half is eating carrots, salad, and water. Okay? So can somebody tell me what they see happening with the two inverses along the black line? What would you say they are of each other?
Opposite each other?
Say again?
Are they opposite?
Opposite? How about mirror images?
Yeah.
That's what I was trying to get y'all to say.
They're symmetrical.
They're mirror images of each other. They are symmetrical around the 45-degree angle. Does everybody see that? Write that down because that's what inverses are. Write that down. Inverses are mirror images of each other. Inverses are mirror images of each other. Now, I'm going to ask you about inverses graphically, like I just did right here, or I'm going to ask you to do it algebraically. So you need to write that down too, because that's the two test questions that I will ask you on this, okay, on this section. So there's how you do it graphically. Use your graphing calculator. What about algebraically? Here's the function we started with. F of x is equal to x squared. What do you do to find the inverse of a function algebraically? The first thing you do, use x's and y's. So I'm going to make this y is equal to x squared. Number one, use x's and y's. Number two, switch them. So x is equal to y to the second power. And then 3, solve for y. So take the square root of both sides. Y is equal to the square root of x. And I added that y inverse because square root of x is the inverse of x squared. Now that is a perfect example of what I would give you on a test to solve algebraically. Oh, excuse me, I'm sorry. Question, gripe, complaint. Okay, I am not going to finish 4.3 today because I don't want to, because you already got 4.1 and 4.2 to be working on. So I'm going to go back to the homework and check to make sure that all 3 sections are open. And I only see 4.1, so I'm going to turn on 4.1 and 4.2. I didn't look to see if there was any questions today, so we'll reserve questions for Thursday. So I'm going to go here and let me look back. I'm going to assign 4 points. Go ahead and assign that one. And assign that one. Let me go ahead and assign the, let's see, what are we on? Chapter what? 4? That one is, what about the quiz? Chapter 4 quiz. It's also assigned. Okay. All right. Now all those are assigned. Let me look and see if anybody's sent any questions. I haven't looked. So I'm going to look at that right quick. And my, hold on, my Outlook is gone. $109. Okay, I only see one question. Let's go ahead and that's 4.1. 4.1. Okay, consider the functions x and x minus 2 plus 1. Sketch graph. Okay. So I'm going to delete, well, I got to delete it to see, you know, what you did wrong. So I'm going to delete that. And I'm going to clear. All right, the first one is y is equal to the absolute value of x. So y is equal to, and it's a 1-to-1 right there. There's the absolute value of x. Now, the function they're showing us with this one is +2 and +1. So that means I'm going to draw a second one at +2 to the right and +1 up. And it's a 1-to-1 also. That's what I got. Save and check. I believe that this one was off by 1 going up. I'm not sure, but that's the right answer. Which transformations are used to obtain the graph of the second function from the first function? Well, the +2 or the -2 and the +1. That would be 2 places to the right and 1 place up. And 1 place up and 2 places to the right. That's it. Okay. I don't want to finish 4.3. I want to leave that for Thursday. So I need somebody to put in your notes, finish 4.3. Okay, thank you. That would help me out tremendously. I'm going to go to the roll. I'm going to cut this out and cut this off.